Hi, my name is Sandro Mancuso and this is Codurance Screencast. In this screencast, I'll be showing how to test drive an algorithm without making any assumptions about its structure or design. In this case, I'll be creating a Roman numeral generator, which will generate a Roman numeral according to a given decimal number. I will write the test first, and then focus on writing just enough code to make the test to pass, only using simple constructs. Once the test is green, I will look for opportunities to make the code better, removing duplication, identifying patterns, and generalizing the code. The first thing that I'm going to do is to decide on the name of the class that will have the behavior of generating a Roman numeral. So in this case, I'm going to call it Roman numeral generator should. And what the Roman numeral generator should do is to generate a Roman numeral for a given decimal number. And the test would be I want to assert that a Roman for 1 is I. So now I need to make this compile. So let's just start to import this, So this is the method that I want to test. So I'm gonna put that into my Roman numeral generator. So that's the class that I want to have. So let's create that. Okay, let's move that to the other side. Let's make that a little bit bigger. And this is the method that I want to have. So this method will return a string, and this is my decimal number. And let's make it, let's return null for now. So, oops, let's start to import this. Okay, so that sounds a good test for me. And let's see if we can run this and see if we get the test failing for the right reasons. So excellent. We are expecting I, but we got null. So now what we need to do is to write the simplest thing that could possibly work. So I'm gonna just return I and see what happens. Cool, so we have our first test passing and our first feature done. So I want now to go for my second test. So I'll go for a very simple one again. Go for this one. So if I pass 2, I expect 2 I's or double I. Okay, so now what I will do is to do the simplest thing that could possibly work. So if decimal equals 2, return double I. Okay, excellent. Second test done. When test driving algorithm, sometimes we don't know how the solution will look like. So what we need is, we need to have more code. We need to have code to give us feedback. So sometimes we write tests in order to force us to write code that is similar to the code that we already have. So we need to start forcing duplication just to see how things would look like. So for example, what I could do now is to do this. So let's go for 3. And of course this is gonna fail. And before I try to be clever, I'm gonna once again write the simplest thing that could possibly work. So if decimal equals 3, return triple I. Yeah, no surprise, it passes. And the interesting thing about this test is that it forced me to see some duplication now. Because now if I look at my production code, these two if statements are the same, but not just duplication I can see there. I can also see a pattern. I can see that as the decimal number grows, the number of i's that I append also grows. So I'm going to generalize this code now to, so I would say for int I equals 0, where I is more than decimal and plus plus I, what I will do is I will append i's to a variable, and I will return this variable. So let's create this variable there. And I believe that I don't need this anymore. That's for my tests. Okay, so what I've done was I went from code that was duplicated, I identified the pattern, and I just removed the duplication and generalized my code. The next test is an interesting one because in theory I could go for 4, but 4 is an exception in Roman numerals because normally in Roman numerals you always append numbers. 4 is an exception, you prepend. And I don't think that my algorithm is mature enough for me to start working with exceptions. I don't have a pattern yet. I don't know, this algorithm is not mature enough. I still need more information. I think that I'm not ready to work with 4 that is an exception. So what I'm gonna do, I'm gonna jump to 5 now. So let's see, of course, that this is gonna fail. And one thing that you don't want to do is to use very complicated constructs. You don't want to use a switch case, for example, because constructs like switch case, they, once you start using it and adding more cases to it, there's no way back. You cannot refactor that. And ifs with else's are also very complicated. So I prefer to use the simplest thing that I could possibly do, and that could be this. If decimal equals 5, return b. I don't want to make any assumptions on the design at all. I just want to do the simplest thing that could possibly work. So at this case, then 5 passes. Now that I have i's and v's, I want to combine the two letters, I and v. So my next test, because I'm not done with them yet, so my next test I want it to be like, for example, 7, where I take 5 and add two i's to it. So if I run, what I could do here is, if decimal is bigger than 5, I want to say, I want to append v to Roman, and I will want to subtract 5 from decimal. So if decimal comes in as 7, it will come here, it's bigger than 5. I will append v to it, and I will take 7 minus 5, it will be 2. So then it will come to this for loop as 2, and it will append 2 i's to Roman. Excellent, that works fine. Now I believe that I'm ready to introduce a new letter, so I'm gonna go for 10 now. So let's run the tests. Okay, it fails. So once again, I'll write the simplest thing that could possibly work. So if decimal equals 10, I want to say Roman, I want to append X to Roman, and I want to say decimal subtract 10, and then that would skip the rest of the code, because then decimal will be 0 and nothing else will work. Okay, that sounds good. I want now to combine X, V's, and Y's. So what I will do, I will say, let's say 18. So if I run it, okay. So what I need here is, if something is bigger than 10, I want it to come here. So I think that this should make the whole thing work. Cool. I can clearly see duplication now. So this block here is exactly similar to this, it's exactly like this one here. So in order to remove this duplication, I need to start mapping Roman numerals to decimals. I'm gonna use an enum in Java. So I'll say enum, I'm gonna call it Roman to decimal. And I want to say 10 will be X to 10, and 5 will be V to 5. So let's create. So this is the Roman, this is the decimal, and let's create the fields for this. So now I have something that combines Roman and decimals. So what I want to do is I want to iterate through these two guys here and reuse these if statements. So for each one of them, I want to execute an if statement like this one. So the way to iterate through enumerators, in this case, if you're using Scala, you can use a tuple, you can use a map, you can use other things, a dictionary, whatever you want. I decided to use a enum. So what I want to do is Roman to decimal, Roman to decimal. So I will take each value of my enum. Let's minimize this a little bit. So for each iteration of my for loop, what I will have stored in this variable is either this line. So the first time it iterates, it will be this line. Second time it will be this line. What I want to do, I want to execute this if statement here. So I'm gonna copy it in here. But instead of 10, what I want is the decimal value of my enum. Here, I want the Roman value. And here I want my decimal value. So I believe that if I comment this out and run, so this should work. Yes, it does. So excellent, I can delete that as well. So up until now, what I've been doing was writing very simple tests and writing very simple solutions. No else's, no switch cases, no extract method, just very simple solution. Identifying duplication and removing duplication. That's what I've been doing so far. So what I would like to do now is I want to go for something that stays on the same letter. For example, 20 or 30, where I stay on the same letter, I stay on the same X, for example. So if I say 30, that means that I need to do X 3 times. So let's see how that works. Okay, it doesn't, because the first time that it here in the loop, what happens is it comes to the loop. The first iteration of the loop, I'll have 10, and then in the second iteration of the loop, I will have 5. What I need is that in the first iteration, I have 10, and I need to stay on the 10. I need the second iteration to stay on the 10, and the third as well, which means that what I want to do is I want to execute this if statement more than once for the same letter while this is true. So instead of an if, I'm going to convert that to while. And if I run that, yeah, it does work. So yeah, that's quite interesting. So I'm happy. So looking at this code now, I can see another duplication. I can see that there is this loop here that appends letters to Roman, and there's this loop here that also does the same thing. I believe that I can reuse that, and what I could do, potentially I could do just this. I could create one here, I put I, that's one, and this. So doing that, I assume that if I comment this out and run the test, that potentially would work. And it does. Awesome, so I can delete that. I believe that now my algorithm is sort of mature enough. It knows how to deal with a lot of things. And it's probably time to start thinking about the exceptions. I want to work with 4 now. So I think that it's time to solve 4. So it's Ivy. 4 is a complicated one because it's an exception. So far I've been appending letters, and now I need to prepend. And this will destroy my algorithm completely, I assume. Unless I treat 4 as if it was a new letter. So what I could do here, I could say 4 will be treated as a normal letter. So if I run that, awesome, that works. And so I believe that if this will be the same thing for 9. So I can now treat all my exceptions as new letters. So if I say 9, that is IX, I can create 9 here. And now I have a common way to deal with exceptions. I just need to treat them not as an exception, but as if they were new letters. And that would work fine without changing anything in my algorithm. Okay, that was pretty cool. I think that if I can treat all my exceptions here, let's see, I think that I can do 40, that is an exception. So 40 is this. Then I have 50, that is L. So this is 50, this is 40. Another exception will be 90. So 90 is XC. And then I have 100, that is C. I have another exception that is 400, that is CD. I have 500, that is D. I have 900, that is 100 minus 1000, so that is 900. And I have 1000, that is M, and that is this. I believe that this covers all the Roman numerals, and to test that, what I could do is to say, so first a test like what we could say 2, 6, 8, 7, let's say. So this is 2000 2 amps, 600 is DC, 80 is LXXX, 7 is VII. So if I run that, wow, that passes. So let's just make sure. So 3499. So a few exceptions in there. So these will be 3000 MMM, 400 is CD, 90 is XC, and 9 is this. Is that right? So let's see. Yeah, perfect. So I think that this algorithm solves all the Roman numerals from 1, 2, 3, 999. And yeah, sounds pretty cool. I don't think that I would have gotten to this solution if I tried to design this up front. I think that the biggest realization for me here is it's just working with very simple constructs, not using else's, not using switch cases, not like just bare minimum, focusing on writing just enough code to make the test to pass, and then identifying duplications and remove them. Also, I think that the choice of tests, some tests, they forced me to cause duplication. And when you are working with an algorithm, that's what you want to do. You don't know what the solution is, so you need more code in front of you to start looking at patterns and then generalize this pattern and make your algorithm more generic. And I think that I'm not sure if you can follow these small steps for every single algorithm, but this is not the first one that I was able to do this. So more and more I'm convinced that you can test drive an algorithm test by test. But let's see, I'll need to try other algorithms. I hope you enjoyed it. Thanks for watching and see you next time.